Very good morning. In this session, we will see about sequence modeling in Unit 3 in the course IT22043 Deep Learning and its Application. The main objective of this session is to study the probabilistic models and autoencoders. The main outcome is to examine the modeling aspects in neural network architectures. These are the textbooks we will follow in this session. This is the course syllabus for Unit 3. So, what is a sequence modeling? It's like giving you a picture of a ball and asking where it will go next. It can go in any direction. But what if I give you the trajectory of the ball and ask you where it would go next? Your brain will relate ball's past trajectory and give you an intuition saying that the ball will go to the right. The same way, deep sequence models are used when your model has to remember information across different time snaps, understanding the relationship between them and then predict what will be the next best move. So, sequence modeling is a machine learning approach used to process and analyze sequential data where the order of element matters. It involves predicting, classifying and generating sequence such as time series, natural language, speech or biological sequence. Sequence model capture dependencies between past and future elements to make informed predictions or coherent outputs. Next, what are the different types of sequence data? Sequence data comes in various forms. First one, time series. So for example, stock prices, weather data, sensor readings, which will change in course of time. Next is text data, sentences, paragraph, chatbot interactions. Third one, speech and audio, voice commands and musical signals which are related to time. And then biological sequence, DNA and protein structures. So what are the basic different types of sequence model? So first one is the many-to-one. A model where your network is fed multiple inputs and is expected to output just one value. So this example, sentiment classification. You feed your model with a continuous string of words and expect to output one sentiment. Next one is one-to-many. A model where your network is fed only one input and you are expected to give multiple outputs of variable length. Image captioning. So you give your model one image and your model will output a description of what the image is about. Third one, many-to-many. A model where your network is fed with multiple inputs and is expected to give multiple outputs of variable length. Example, machine translation. You give your model an English sentence and your model will translate it to French. To design a sequence model, we need to handle variable length sequence, track long-term dependencies, and maintain information about the order and share parameters across these sequences. Next we will see the different models available in sequence model. So first one is recurrent neural networks. It is designed to handle sequential data by maintaining a hidden state that remembers past information. It uses a loop mechanism where the output of one step is fed into the next step. Its limitations are it struggles with long sequence due to the vanishing gradient problem. And second sequential model is long short-term memory LSTM. It is a type of RNN that addresses vanishing gradients using gates to control memory. It includes forget, input and output gates to selectively store or discard information. It is suitable for tasks like machine translation and speech recognition. And third model is gated recurrent unit, a simplified version of LSTM with fewer parameters. It uses update and reset gates instead of multiple gates in LSTM. It performs well as LSTM, but it is computationally more efficient. And then the last model is the transformer or attention based. Unlike RNN, transformers process sequences in parallel, making them faster. It uses self-attention mechanism to learn long-range dependencies. It is popular in NLP models like BERT and GPT. These are the some of the applications of sequence model. So first application is text generation, GPT based chatbots, story writing. Second application is machine translation, Google Translate, multilingual AI. Third application is time series forecasting. Example, stock market prediction, sales forecasting. Fourth application, speech recognition. Example, Alexa, Google Assistant. And biological sequence analysis. Example, DNA classification. In summary, sequence model captures temporal dependencies. Sequence model process data where the order matters, making them ideal for time series forecasting, speech recognition, and natural language processing. It uses specialized neural networks like RNN, LSTM, GRU, and transformers, which are designed to handle sequential patterns by maintaining memory of past inputs. And its application is across domains. Sequence modeling is used in machine translation, stock market prediction, speech to text conversion, and DNA sequence analysis. Thank you.